Welcome, everybody. As Ryan said, this is the panel on the intelligent edge, and I think I know why they put us in the last panel of the day, where that line between you all and happy hour is, because I think it's really the most fascinating topic that they have going here today. I mean, it's, when I started covering the market in 1996, which just seems like yesterday, the big thing was client server. That was revolutionizing, IT. They were putting computers on your desk, and it was just changed the way we worked and lived. And I see the intelligent edge really doing that same thing. Though I have to be frank with you, I'm not an expert on it, and sometimes I kind of struggle to understand what it is and all its implications. And that's why we have this great panel with us today to talk about that and to, explore it and answer your questions and my questions. And we should walk away knowing much more than we did walking in the door. So our panel, we have Ian Doyle, who's the Executive Security Advisor with IBM Federal. He works with federal customers across all of IBM's security offerings. This includes IT security, risk, and compliance. And he's also worked extensively with DoD as well as Army Cyber Command and NetCom. He's a graduate of VMI and has a master's degree from Mary Washington University. And our second panelist is Ashish Parikh, Vice President of Internet of Things, IoT platforms from Arrow Electronics. He leads the IoT platforms and solutions organization at Arrow, and his team is responsible for Arrow Connect. And hope I can explain this right, but it's a solution that allows a connection between any sensor through any gateway to any cloud. And in this day of hybrid environments, that's a pretty powerful solution, I think. His team also integrates communications, IT services management, billing, and provisioning. He has both a bachelor's and a master's degree from the University of Texas at Austin. So thank you both for joining us. What I'd like you both to do is just take a few minutes and kind of talk about how you define the intelligent edge, sort of that 101 level to kind of get us all in the same playing field. And then we'll jump into questions, and then I'll open it up to y'all for questions. So,
okay. Ashish, please go.
All right. Good afternoon, everyone, and thanks for being here today. So, can you guys hear me okay? Excellent. So, the intelligent edge is really about making real-time decisions. And I think the best way to explain it is what you're going to see after you walk out of this room and go to the expo area. And in the corner, you'll see this car there. It's the SAM car. It's the SAM car that Arrow helped build to enable a guy named Sam Schmidt drive the car. Now, what's so special about it? Sam Schmidt is an IndyCar race car driver. In 2000, he hit the wall at about 150 plus miles an hour and severed his C4, C5 and became a quadriplegic. He only has movement from the neck up. He is in a wheelchair for the rest of his life. But he is a race car driver. He owns a team today, an IndyCar team, and he drives that, he basically wants to make sure he's a winner. And about 4.5 years ago, Arrow and Sam got together, our CEO, as many times CEOs do, made this audacious statement, Sam, we're going to get you driving again, which was great, except Sam said, I have to be able to drive more than 100 miles an hour. Of course, no problem. So what you're seeing there is really the second generation of that car. And what does this have to do with the intelligent edge? Sam drives that car by using his head movement. So moving left and right is how he steers the car. He uses a sip and puff sensor to accelerate and brake. That's it. Simple. Now, in the back of the car, in the trunk, are a bunch of computers that are taking the movements, the physical movements, translating them into electronic signals and controlling the car. He's going he's gone 152 miles an hour around the Indy Oval. He's gone up Pikes Peak. For those of you who are from around here and don't know Pikes Peak, it's in Colorado. It's this crazy windy road. I forget how many turns, but I think if any of us were driving, we would get pretty dizzy and would be sweating. He did that in about 15 minutes. He has a provisional driver's license. it has enabled them to do things, but it's because of all that edge computing, the ability to make real-time decisions, right? You can't go to the cloud and then wait for a command. You can't have a hiccup and have something fail. And that's really how I would define the intelligent edge.
I would definitely agree. Hello, everyone. So my perspective, obviously a little biased from a cybersecurity standpoint, but to add on to what Ashish is saying, that we've seen that evolution from what was a perimeter defense to how we're moving to cloud or moving to mobility platforms, right? And now to these intelligent type of devices. The perfect example, or you start to get into DoD perspective of drones or medical devices that are implanted in our bodies, but yet it's collecting data. And I think it comes down to what type of data is it generating, collecting, using, but then from a security perspective, how are you securing that piece of information or that data? And everything is not a client server or an endpoint that you can just throw an agent on or monitor it, but it's how are we going to utilize technologies to adjust. If there's a breathing adjustment in this car example, right? No, does he really mean to do that? Does he not, he or she? So I think the intelligent edge is really pushing out that what used to be perimeter type of network boundary discussion to wherever that network or that technology exists today, and how is it communicating back to an on-premise type of environment.
So what's the customer need or what's driving the demand for needing to do that?
Look at our kids today, right? They have a need to be connected. They have a need to use technology, and it's not just technology in the house. It's technology whether at the movies, with their friends, wherever they may be in the car, right? And very simplistically stated, but how we're using technology and being connected today just continues to move further and further away from the point of origination, I think.
Yeah, to add to that, it's there's a lot of data being generated, right? When you talk about sensors and volcanoes, there's a lot of data being collected. And yes, you may want to store the raw data, but if you need to make some real-time decisions, you need to make that decision right there. And I think the advances in computing is enabling that, but really what's driving it is you have to make the decisions because you don't have time to make the round trip somewhere else, analyze it, and come back.
Okay. So can you talk a little bit about, I guess, what are the advances that have been enabling this? What are the kind of the key? Because I assume you have to have a certain kind of infrastructure in place to.
Yeah. So I'll go first. And so there's, when you talk about computing, some of the things that are happening, the silicon vendors to start with, right? People who are making the chips that go into the edge, intelligent edge devices. They're starting to incorporate more algorithms that can be processed on the edge. They're getting the know-how how to mix analog and digital signals together and do that computation right there on the edge to give you that real-time feedback loop. So that's one. On the cloud side, you have machine learning, analytics, neural networks. These are the things that are really enabling a whole new set of applications. And while you can do a lot of it in the cloud, really the way it works is that you train the model in the cloud, but then deploy it on the edge, right? So it's a combination of those two things. And then the third thing I would say is the GPUs, or the graphics processing units. Most familiar with video games, right? That's really where GPUs got their start, and for the last 15 years, GPUs were the things that went into Xboxes and in PCs because you wanted that real-time gaming experience. But the other thing that GPUs are really good at is floating point calculation, so advanced math calculations. You're able to compute lots of things very, very quickly, and that's really being used in machine learning, in analytics, in video analytics, and I think those are the three core technologies.
Right, I agree. And these sensors, which at a point in time were just collection devices, but now they're essentially smart sensors. And going back to Scott's discussion with, at some point in time, maybe decades from now, there may be a space shuttle that gets you from here to Tokyo in 30 minutes. Well, same holds true of these sensors that were collection now to smart sensors, doing the analytics, having the machine learning at them at the point, and they are doing a lot more than we were doing 10, 20, 30 years ago. So I think there's a significant advancement in the technology and how we're utilizing those sensors and what we're doing with them at the edge.
So think about the mission, or the particular, what kind of missions are best suited for the intelligent edge?
I don't think that there's a best mission, but I mean, I could rely upon some of my defense background that, I mean, you look at drone technology, right? Or you look at, deployed forces, where we traditionally always wanted to make sure that we deployed our forces with the best munitions, for example, as possible, because we know they're going to be disconnected. They may have limited comms, but now we want to also give them the best technology possible. So they may not be connected to, the right intelligence, be it blue force tracking or threat intelligence to know where the enemy is, but we are giving them that technology that they can work autonomously as they deploy downrange. Same holds true with the drone. It is an extension of our military forces to take some type of action, whether it just be collection or, to fire a missile. So I think, in the military specifically, the intelligent edge is having a huge impact on what we're doing in today's times.
Yeah, and I think to add to that, when I thought of, the context we're in today, I thought of missiles, right? I mean, that's the ultimate intelligent edge, right? You're making a lot of real-time decisions in terms of tracking a target and making sure that you're avoiding certain things and you're, going after the right thing. I think from a civilian or also from a government perspective, I think video analytics is an interesting application. Again, security is a big problem today. Just understanding behavior, emotion, and you'd be shocked to learn how much you can get from video cameras these days. And a lot of these algorithms are out there in the public, but it's how do you put it all together as a complete solution? And they could be really simple applications like people counting lines, right? How do I optimize that in a grocery store or at a checkout line somewhere else? Those are some simple examples, but the more complex examples are really around looking at people behavior, threat intelligence, looking at, applications like parking spaces. You're starting to see a lot more of this where there are sensors deployed with a green light or a red light that tells you a spot's available or not. Another way to do that is just cameras that are counting. License plate recognition is another one around. Again, you want to do a lot of this locally.
So what, if you want to, if you're a contractor and you want to move into this space, are there particular skills that you should be trying to acquire? How do you prepare yourself as a business to move into this emerging marketplace?
I'd probably say that there's so many platforms in so many different directions that these intelligent edge types of devices or smart sensors are going. I don't think there's any one particular area, in my opinion, but I think it's overall being immersed in all these different types of dialogues from threat intelligence and how is the information being moved, and ultimately it comes down to the data itself. So where is the data being generated? How is it going to be moved back either via cloud, direct, or held in place until it actually reconnects to a base station? So I think that there's I don't think there's really a good answer, in my opinion. I don't know, Ashish, if you...
As I think of what skills do you need every skill that's known to man to do this. And seriously, when you talk about Internet of Things and you talk about IoT is not one technology. It's a lot of different technologies. And no one person, company can do it on their own. So I think for a contractor, it's figuring out what's your niche, right? Where can you really add value? Is it on the front end of the discovery process? Understanding the use cases and talking to customers and figuring out what problem they're trying to solve for versus somebody who may be a data scientist, right? Who understands how to take that requirement from customers and translate it into technology, whether it's on the edge or the cloud. But I think, if I had to kind of pick on some things, I view there's a big chasm out there between the edge and the cloud, right? The operational technology side of the world and the information technology side of the world. And really it's, people are experts in one or the other typically, not both. Very few people are, if you take some of the hardware vendors like Apple, Samsung, they have vertical capabilities that can span from edge to cloud, but most companies don't. And so the ecosystems and partnerships you had formed there, I think, is probably a critical thing that they need to solve for.
So it sounds like, I mean, you need to, start with understanding sort of what the use case is and then sort of build the solution from there. Okay.
I would agree with that.
Now, are there any, like barriers to entry to get into this market? I mean, what are challenge, what are the challenges kind of exploiting it?
So barriers to entry, I mean, it's easy to get started. The challenge is how do you go from that easy start to scale with security and end-to-end security in mind. When I say it's easy to get started, how many of you here are familiar with Raspberry Pi, which is not the thing, very good, about half the room. Not the thing you eat. It's called a single board computer. It's about yay big, fits into an Altoid can, and my kids use it to tinker around. And the idea is you can connect sensors to it and actuate motors and do different types of things with it. So easy to start, but can you take that and make it a mission-critical production service? No, it's not designed for production. So you really want to kind of think of easy to get started, but then again, to scale, you need the right partnerships and ecosystem to enable you.
Talking about Raspberry Pi, I think of, I was at, I don't know if anyone went to DOTUS this year in St. Louis, but there was a kid who started his company, went up on stage, and using a sensor, smart sensor, it was a teddy bear that talked to children, and he was able to break into the code and then connect to every single person's telephone via Bluetooth who had Bluetooth on, collect all their information, and then take ownership of their phones by utilizing a smart sensor. Obviously not the intention of what this teddy bear was for, but being able to manipulate these smart sensors. So what types of barriers? I mean, first of all and foremost, IoT from a security standpoint, I don't think it's truly defined. So how are we securing these IoT devices? I don't think we have that in stone, and these IoT devices continue to proliferate and come out with new ones, these smart sensors all the time. So we're sort of in a catch-up mode from that barrier perspective, but also and there's huge privacy perspectives in place that, okay, well, when you do put, or you learn about it, or if you do putting out new devices, how are we trying to ultimately protect that data?
Yeah, if I can just jump onto that. I think, I probably get one or two startups contacting me every week about security, right? And it could be down at the chip level or in the cloud. But I think when you talk about security, really, it's not one or the other. It's not having a firewall. It's not just about doing the advanced analytics and looking at the patterns and trying to figure out. It's how do you secure the device, right? How do you identify the device? And it starts at the silicon level. How is that chip process? Is it authentic? As it gets integrated, how do you identify that? How do you secure the keys in a one-way, write-only, so that nobody can ever maliciously do that? There are hardware solutions out there that if they're tampered, you can basically just delete everything or whatever you want to do as the security protocol may require. This message will self-destruct in 10 seconds kind of a thing. You could enable with hardware solutions. So it's really a combination of hardware and software that's critical there.
Absolutely, and I can give another example too. We, as users of these smart sensors, right, we go back to there's a terms and conditions when you're using software or you're using some type of new device. Well, when it comes to these IoT sensors that we all use, think about going into a grocery store. And this is a true example where, we all have our little key cards or our, smart numbers that we know we get certain savings or we get certain, discounts. But what is being done with that data on the back end, right? Do we truly know and acknowledge and want to agree with how that data is being used? And the example I'll give is that there is a customer that went into a certain grocery store and started a buying behavior pattern of buying certain items. milk, or so on and so forth. Well, as a result, knowing that buying behavior based on all the other data they collected on those smart sensors of all those little, scanned cards, they started sending certain coupons to the house. Coupons being for pregnancy and for new expecting mothers. Well, come to find out that this was going to a house of a teenage girl who had not told her parents yet that she was pregnant, and then only for the parents to find out, why am I getting all these, new motherhood coupons from this grocery store specifically because of her buying behavior? And so there were some ramifications as a result. But again, how is your data being used on these smart sensors, and do we truly know as an audience how that data is being used?
So we're taking over this conversation. So
That example kind of blows my mind a little bit.
well, so to give you another and kind of paint the picture, right? Nest, right? The thermometer, right? Again, it's a combination of edge and cloud analytics. Really well done, and there's a lot of information there, right? Think about the implications. In that thermometer, locally, there's information that says when do you enter the house, when do you leave the house. What's the temperature? Yeah, somewhat relevant, but the entry and exit information is critical. And if somebody had access to that data, again, think of the implications there. So making the entire system secure is critical, right? You can't just say, yeah, my data is safe in the cloud. It has to be safe on the edge and tamper-proof on the edge.
Wow. So how do you know if your customer is ready to take this step? I mean, are there particular questions you should ask them? Or are there particular?
I think if you followed a sort of like a maturity model to get a baseline of where they are from their networking, their computing, their application usage, I mean, even adoption of cloud, and first and foremost, we talked about, a defensive perimeter to extending that perimeter to cloud or mobility platforms, and now to these smart sensors, getting a true understanding of where they are along that progression line, and then making an educated decision as far as, okay, well, this makes sense for a smart sensor here, even if it is, you may be starting to collect additional information to build up, either defenses or other communication means in their perimeter type of networking, before just jumping in to say, hey, I'm going to start flying drones and deliver pizzas all over the place because I'm ready to do it. So I think there's sort of a maturity model that has to be followed and sort of investigated.
I would say, if you have a SKU and you can sell it, then you're ready to sell it. All right, that was a joke. I think it really starts again with the use case, the business problem, right? What problem is the customer trying to solve? Ian and I come from very different sort of parts of this conversation, but as we talk to customers, and whether they're federal customers or in the commercial realm, there's a business problem and you need to solve the business problem. Because if there's no business problem and you're just putting smart sensors because, somebody else is doing it, probably not a good enough reason to do it. You want to go find the key business problem. Every business has problems, right? Businesses have a lot of buildings. How do you want to manage those buildings? Not all of them are LEED certified. We're talking to a big contractor a couple months ago, and one of the things that he said that they have a lot of government contracts in managing buildings, and one of the biggest problems that they have or the government has is actually knowing where their buildings are located. They don't even know where their buildings are located. So when you talk about asset tracking, this was like, how do you not know where your buildings are? But these are real life problems of the U.S. government right here. So.
Yeah, that's definitely use case driven, and that's a perfect example. If we're talking about trying to accelerate, computing for whatever reason, well, if it's down to asset management or if it's down to, more simpler types of, I guess 101 level type of configuration management, asset management, then maybe it makes more sense. So it's really use case driven.
But it sounds like you really need to understand, like you're saying, how do you not know how many buildings you have? How do you not know how many data centers or servers? I mean, so you really kind of have to have.
And there's so many different industries with so many different problems where this technology can be beneficial. But if you approach it with, from a sales perspective of, I need something to sell today, you're probably going about it wrong, right? It really starts in a very different consultative approach of understanding what that person's doing, really understanding their business, and what you bring is the expertise either in the technology or the process, and marrying that together. You're listening to them actively to understand, I'm trying to solve for this problem, and then I have, you know, a bag of tools that I can basically pull together and create a solution, but it's not a SKU. There are very few things today for IoT that are SKUs. There are definitely, you know, solutions like Nest that I talk about, right? Yeah, you can get that off the shelf, but it's solving a very, very particular use case. You can't take Nest and deploy that in, you know, a government building or a commercial office. It's just different, right? The needs, the requirements of management, security are different. And so you just have to think of all those things together.
And clearly, in our customer set, in the federal government, you know, they don't historically move very quickly. So there's an adoption period, there's an integration period, there's an implementation period. And I'm not just talking, you know, milestones of, you know, 12 months, but, you know, how long has the government still been adopting mobility, still been adopting cloud, right? If they have yet, or, you know, still, it's going to take a methodical process. So it's, again, answering that use case with those specific requirements, and it's not just going to the operator saying, ooh, it's a cool technology, yeah, I want to do it, but how are you truly helping them move the maturity level of, you know, their overall mission?
So when you look at your customer, they have to have certain things in place? Because I'm thinking, you know, that during the civilian briefing this morning, they talked about census and that, you know, some of the delays are going to be doing still a lot of paper-based collection. I mean, should an agency have already sort of, you know, digitized their processes before they move out to the edge, or can they just leap from paper right out to the edge? Or
you think they would have, but I bet you those are some of the buildings that they lost sight of that have paper in it. So,
I think I don't think it's necessary. I think it's, again, it's steps, you know, towards digitization. Not in the government space, in the commercial space, but one customer we have that's in the industrial material handling business. What is industrial material handling? Think of loading docks, right? Every warehouse has one. You know, you got loading docks. That's how trucks come unload their materials. These are business critical things, right? If that loading dock stops working, that means you're losing capacity to move products into the store. If you can't move products into the store, you're not able to move them off the shelves, or they're not available on the shelves, your customer goes somewhere else. And, you know, 6 years ago, they started that digitization journey. 6 years ago, they had their field technicians doing stuff on paper, and it was inefficient because they would have to go out to the customer site, look at what it was, right? Customer called, drive, check it out. Okay, I think I know what's wrong. I know what system's implemented here. Drive back, come back with the parts, try to fix it, you know, hopefully the first time they were out there. And, you know, the first step of that digitization is the configuration management and understanding all their customers, all their installed products in a system. Right, and with that, they went to an industry-leading 85% first call resolution on that. Their next sort of journey that we're embarking on with them is they want to build a solution where they can go to 99+% first-time resolution, which means they know what's wrong and they can fix it remotely. They can dispatch a technician if needed, but only if needed. You know, as much they can do remotely, you know, it's going to be beneficial for their customers.
so was their goal when they started, was that resolution rate to get a certain percentage done the first time, so they had a clear vision of what they wanted to pay
They
off?
definitely had a clear vision of how do we adapt that technology, right? And it wasn't just one technology. It wasn't just about putting that. It was also enabling their technicians to use iPads to see the information in real time. It was giving them a lot more information and access that they didn't have access to before, because before it was in file cabinets that potentially could get lost and you'd lose buildings.
So Ian, is anybody in the government space being a leader in this that you see, or any use cases that you can share?
So we talked a little bit about the drone. Another use case that I would point out, and again, goal in mind, requirements, and the perfect use case was from air maintenance. So just like, I work with a number of you here, my second office is in a plane. So I don't know how many times I'm in an airport going to my gate and like, oh, unscheduled maintenance. Well, why is it unscheduled? Why didn't you know that this had to be done, whatever the widget was? So in the Air Force specifically, being able to hook up their planes to smart sensors to know when a plane has to go out of commission for certain scheduled maintenance, a scheduled outage per se. So this way they're not having to impact a mission or impact their flight time when they're doing transportation or so on and so forth. So being able to basically have that onboard system of knowing, all right, I have to have the oil changed, or I have to change my wheels, or I have to do so many of these patterns, and not having to rely on the pilot or the pilots going around the plane doing a visual check or some other type of computing check and not knowing about it until after you've already landed. It's preventing or doing the predictive analytics on these smart sensors to say these planes need these before they impact a certain level of flight.
So you need to have like an analytics engine in the background.
Mm-hmm. But it's collecting all that information from the smart sensors, going with all the different widgets on the plane itself.
Yeah, speaking of planes, the project where IBM and Aero have worked together is really around an airport. Again, it's in the commercial space, but the airport's a little bit north of here, and in the wintertime, the gates have what they call portable water cabinets, right? This is when the plane pulls up, you have to refill the water, and you can have drips. Somebody may not close the door properly, and when it's really cold outside, those things freeze. If they freeze, again, the challenge you have is the plane doesn't have water, you can't let the plane push back, you have to literally take, hair dryers sometimes and thaw it before you can fill the water and have the plane push back. Now, why does this happen? It's not because somebody was malicious. Sometimes there's a drip, right, and it starts to freeze inside that portable water cabinet. So it's, again, going from the reactive maintenance to the proactive maintenance of saying, hey, somebody left the door open, dispatch somebody to go close that door. That's it, simple. But now that's saving tons of time and money and improving the customer experience. Motors are another one, right? Moving walkways, escalators. I took a picture, and I can't really get it onto the slide, but I'll describe it to you. Jason and I were at a trade show here in DC in the July timeframe. It was the Microsoft Inspire show, first day of the show, everyone's coming out of the keynote, the expo's open. I don't know, 50,000 people at this show, and we're coming down a set of escalators, and there's 2 escalators and a stairway in the middle, and one of the escalators is closed, and people are just getting there, and when I get to the bottom, I see a sign that says schedule maintenance, and there's 2 guys in suits, hunched over, trying to figure out what's going on. There are 2 technicians in there trying to figure this out. This is not scheduled maintenance, right? Back to your point, this was, if you had some predictive knowledge about something is going wrong here, right? Whether that's happening on the edge, and how that edge communicates to the cloud and to your IT systems to say, instead of 9:42 in the morning, perhaps at 6 o'clock in the morning, if we had fixed it, it would have improved the customer experience.
Less disruption. I want to throw it out to you all. If anybody in the audience has a question for our panel, you got.
We have incentives.
Yeah. Do we have a microphone?
Just we don't need to.
Speak loudly.
Yeah, I can speak loudly. So it seems like there's some discussion about where the intelligent edge really should stop. Let's say because I was in the IoT presentation before this. And there was a discussion about, smart sensors or dumb sensors, and the idea that maybe you should be making sensors as dumb as you possibly can make them from a security perspective, on the one hand, because it's much more easier to secure something that just sends one very basic bit of information to be processed somewhere else. And on the other hand, cost is an obvious, consideration. So do you think the intelligent edge, how do you determine if it should be in the sensor or if it should be in the gateway? There seems to be a lot of discussion about gateways really sort of taking over as the place where all the security happens, where the processing happens, and even, I guess, potentially where some of the AI may happen, because that was the next logical progression. Sure. Is, where do we do the machine learning piece to make this actionable data?
So where is the edge of the intelligent edge?
I think it's definitely use case driven, sort of a common theme we've been talking about. Sending that particular piece of data that, all right, this widget in the airplane is working is, maybe it's a dumb terminal because it's just a dumb sensor sending one piece of information. Is it green or red? But if you're talking about collecting, someone's their heartbeat rhythm and where they are co-located, and if it is with a, executive or a significant person of interest, then okay, well, that's probably a much smarter sensor that we want to make sure we lock down and we don't allow access to it.
Another project that we worked on, you just don't know about it, is video analytics, right, in a retail store. And again, a lot of this is done today using clipboards and, people who are going to talk to you as you're walking out of a restaurant saying, hey, what did you buy today? And you're just trying to get a sense of demographics and their buying patterns, right? This is done when you go to a Macy's or a Taco Bell, right? People are trying to figure out who's coming there. Of course, at Taco Bell, it's only after midnight. They really... But the challenge that we had in this project was we wanted to use a camera-based system to do the video analytics to kind of understand how do you tie the cash register data to the video analytics and say, okay, this is a 22-year-old female that's buying something, and you can then tie that to that. The one challenge was how do you make sure that that information is abstract, that you're not kind of taking your picture and sending it and storing it in the cloud, because now you're potentially creating some privacy issues. So the intelligent edge in that case is, the camera or a gateway, either way, where you're doing the local video analytics to figure out, who is that person. You're, again, training in the cloud, but implementing in the edge, and the edge is, again, like you said, where's that line? It depends on the use case, but you're making that decision locally and only sending the metadata up. So if it's wrong, but you're avoiding the security issue.
Good question. Got a T-shirt for you.
Okay. Nice.
Yeah.
All right, next one.
Anybody else? Yes, Dennis.
A lot of this stuff is way out there, and what I've noticed in a lot of way out things is that a handful of people jump on board, like small numbers, like 15%. 85% are going to wait for this stuff to be proven. Do you think that 85-15 number is going to stay true in this world?
I think all businesses are realizing, and I think as an extension, the government as a business, I think everybody's realizing that you have to take advantage of this technology. I think there's truth to that number, but I think it's changing very, very quickly, because if you're not using IoT technology, whether it's intelligent edge or in the cloud, just to transform your business, to offer new services, you're going to be dead. Your business model is going to be dead. And let's take taxi drivers as an example, right? Lyft and Uber have upended that ecosystem, right? And there's Airbnb, and there's so many other examples of, again, innovation disrupting. And that's happening even for Fortune 500 companies today. 50% of the Fortune 500 companies that were there in 2000 aren't on the Fortune 500 today. They've either been acquired, gone out of business. So there's a lot of disruption, and companies are seeing that. And more and more people are looking at how to do this. So I think that that's going to start accelerating really quickly.
Yeah, I would agree. I think standard, 80-20 principle sort of applies, but there's that innovation, and what's the next innovation to grow from? Companies that have been around, for 100+ years, that where are they moving towards? And I think there are some slow adopters, but I think it's not just use case driven. Think about in the federal government, where's the acquisition cycle? Are they on an end of life type of technology? Are they being, sort of mandated to do another, mission or operation or goal? So there's a lot of other factors in play, but I think ultimately moving forward that this is the way we're seeing technology driving.
And I think it's, to piggyback off your comment about the Fortune 500, just because, the government market has sort of a reputation being slow, conservative, et cetera. Well, somebody a few weeks ago had quoted that stat to me, and in light of the top 100. So I went back to 2003 and went through, and since 2003, 69 of the companies of the 100 in 2003 are not on the top 100 today. So it just shows a lot were acquired, but does show,
the churn.
The churn. So, Anybody else have a question?
Just as a follow-up.
Sure.
In the other session, they were talking about what some of those hesitations are and reasons maybe why the government and commercial customers haven't moved as quickly with some of this stuff. A lot of that, of course, was around cybersecurity and how do you make this secure from the sensor all the way back. Some of it was around the fact that the gateways are a very important piece of this, but there are so many of them out there, made by so many different companies right now. And, the one gentleman said that, he thinks this is going to compress over the next couple of years, that the number of, gateways out there will shrink as things standardize. But right now, when things haven't standardized, how do you get past that with customers? What's the means of sort of getting, the data from here to there securely in a, fashion that you can convince the customer is safe to move forward with?
First thing that comes to my mind is, great question, is money. So in a non-commercial world, it's not a P&L type of conversation, but it is a budget conversation in the federal government. They have, perceivably a limited amount of money to spend, and what are they going to budget on? Well, if they want to budget on technology that takes advantage of a smaller piece of the pie that they seem to continuously be getting, what technology can they invest in to actually give them more return on their investment? And I think these types of innovations with the sensors, there may be, like to your point, dumb sensor, smart sensor. Well, when do you need additional security, and when do you could say, what, I'm just collecting, is it alive? So all those need to come into play.
Yeah, I would say I wish I had been on the other panel because I would have totally disagreed with that person. I think there are going to be more gateways. There's going to be more hardware solutions that's really very purpose-built. And we're seeing that in the market today, right? They're Intel gateways, ARM-based gateways. Some of them have more capabilities, others have less. What kind of connectivity options do you want? So I think there's a lot of different things happening in that space. I think software is the key to make sure that you can run across all those different hardware platforms and unify them and work across the different use cases.
Yes, sir.
I'm curious.
No.
Mike.
I'm curious, what do you think is the biggest driving factor to accelerating the advance of the intelligent edge becoming more intelligent, if you will? We've already come light years, like you said, with things around the home, whether it's Google Home or Nest or things like that, cars, and we all know all these examples that we hear around us, but what is it that maybe has sped up or is going to speed up that advancement further? Is it just compute power, that you can put more compute power on the edge? If you have any insight into that, I would appreciate it.
Yeah, I think the compute power is definitely one of the key things that's driving it, but I think people are finally figuring out how to solve for different types of problems that are out there, whether it's in agriculture, transportation, asset management, asset health. Example, right, the grasshopper pumps or the donkey pumps in Texas, right? They're drilling for oil. And those things are basically out there in remote areas, and they're just drilling for oil, right? And if there is a change in the bearings and how that thing is moving, again, you have somebody who today goes out there, once every, I don't know how often, and looks at it and says, yep, I think that looks about right. Check. And they're on to the next one, right? And they're doing this, every 30 days or however often. And I think the intelligent edge, in this case, is about making those decisions on the edge, right? To say, hey, I am sensing a change in the vibration pattern that's anomalous. I'm going to have a satellite uplink, right? We talked about computing, but we haven't talked about communication. But I'm going to have a satellite uplink because there is no cell tower in as far as the eye can see here. So it goes up via satellite and just says, hey, something's wrong. Have somebody go check it out. So you're really replacing the route-based monitoring with more intelligence to then direct the efforts.
So what happens to the guy whose job it is to drive from pump to pump?
And that's where I was going to say is, why is there a need? Because of the resources, right? And we're not just, how many people, and you see, cybersecurity alone, we're in a zero-sum market as far as trying to hire the right people to do these jobs. Same can be true. We're growing in technology, certainly, and innovation, but the people that are required to do these types of, platforms and development and monitoring is, we're just, because it's such a hot market, we're all, basically hiring from one another and not necessarily continuing to grow the right people that we have to do these jobs. So why do we rely on then intelligent sensors? Because they're sort of augmenting the human resource. To your point, I don't think that gentleman loses a job, but I think he certainly is repurposed, or she's repurposed or trained to do something else. And I think hopefully there's a retraining program in place that, all right, we have this new technology that we need to sort of, utilize.
I think it's a great catch there. I think we have to go figure out that, if you're going to have 20 billion or 50 billion sensors, or how many ever you're going to have out there, that, a lot of people are not going to have the jobs that they did before. But understanding that, and again, there's a whole social sort of angle to this in terms of how do we address that with education, retraining to enable those people in that field or a different field.
Mm-hmm. Good question.
Because the jobs aren't moving overseas, they're moving into technology, and technology is the challenge, it's not somebody else. And that the same thing's happening overseas as well, by the way, right? India, China, same problem, right? Technology is overtaking, the manpower, and so it's how do you retrain people?
Mm-hmm. In your opinion, is the United States, as a nation state, a leader or a follower in this world?
That was a very open-ended question. You said a leader or a follower in the world. Did you mean world of IoT or?
Yeah, world, yeah.
Okay, I just wanted to make sure I understand, because I was like, boy, we're going to be here for a while.
And probably just clarify a little more, commercially or with the federal government specifically? Okay.
I think there are many places where we definitely should demonstrate a lot of leadership in the core technologies. I think there are other areas, if you look at residential or consumer markets, you see a lot of innovation coming out of the United States. But I think there are many countries that are really deploying this kind of technology for smart cities and smart infrastructure. And I think the United States is actually a little bit behind on some of those efforts. I think there's efforts that are starting to coordinate around some of that. If you look at FirstNet, I think that's a great leadership example of looking, 15 years out to say, hey, what does our next generation public safety network need to look like? And what kind of services do we want to enable? I think that's a great initiative. But there are other areas where we're a little bit behind today. So I think it's a combination.
I would agree, and specifically from the federal government perspective, for every predictive maintenance from aircraft example that we may give, there's the asset management problem, not knowing where buildings are. So I think it's certainly constrained by policy. I think it's also a political conversation as well, obviously with the federal government. So I think overall we're certainly probably on average behind when it comes to adopting that type of technology.
Do we have? Yes, ma'am. Wait for the-
Finally, a question from that side of the room.
That's right. We got drink tickets too.
Yeah.
If you... Oh, I see hands going up now. There you go.
So you guys are from two large companies. How are you getting these CISOs in these smaller agencies to adopt this new technology when they're so adverse to putting new things on their network or change?
Their jobs are on the line. So very honestly, from one side of the paradigm, you're right. Are they a little adverse? On the other side, if they don't make these decisions, they're out. Very simple.
Yeah, I think this is a line of business conversation, not an IT-led conversation. If you're trying to go sell IoT to IT, you're not going to get anywhere. It's the line of business that's looking to either, find new sources of revenue, reduce costs, improve customer experience. If you're not hitting one of those three, and IT is generally about, keep making donuts.
Exactly.
So, and apologies to any IT people here.
Anybody?
Got 2 minutes, one last question.
Yeah. 2 more drink tickets? Sure.
All right. Well, one thing I heard you guys talk about, and I kind of builds a little bit off that last question too, that and your answer, that the conversation with your customer starts. You have to look at who you usually talk to and understand if that's the right person to be going to for this kind of sale. Is that?
Absolutely, yeah.
Yep. Absolutely. Use case, again, not to beat, a dead horse, but also, and then the money piece. Is it a P&L conversation, business line? Hands down. Is it saving budget? Then approach it that way, because I think it's not just IT selling another widget. Oh, it's a smart sensor. Well, do I really need it? It's how are you going to impact their business and their bottom line?
And going back to your aircraft maintenance, right? I mean, there's an impact, right, to operations if
Absolutely.
that aircraft, fighter jet or commercial, is out of service. So.
Mm-hmm.
All right. Well, gentlemen,
Okay.
thank you.
Thanks.
Thank you all, and.